Well, thank you for inviting me all here. I mean, this is my first time in Hungary, so I've been having a real good time. I got here early. I got here on Sunday and was able to check things out, although I think you could do a little better with the weather, so I appreciate whatever you can do on that. At home in Phoenix today, it's supposed to reach about 33 degrees Celsius, so that's nice and comfortable, just so you know what I want. All right. So I'm, as said, I'm Barry Stahl, and of course this has decided to not work now. It was working moments ago. Should we just start over? Hi, everybody. My name is Barry Stahl. I'm a solution architect and developer based in Phoenix, Arizona. And I'm the kind of person that has a list of his favorite physicists and favorite mathematicians. So that's probably all you really need to know about me. It tells you really everything you need. But I'm also the kind of person who likes to argue about such a list, so I tweeted this list. I'm at BS Stahl, and that's usually the best way to get a hold of me anyway, so feel free to ping me on Twitter, and feel free to tell me how I messed this list up, who should be on it, who shouldn't be on it, etc. Right now, the only person that's really kind of on the bubble at this point is Neil deGrasse Tyson. We'll see how things work out for him, whether it turns out to be true what has been said. So he may be coming off this list soon. I also host a bunch of open source projects. I'm not going to go through them right now because we're kind of short on time here, but I do want to point out that this particular project right here, LiquidNone, is very closely, very applicable to this talk. It is a library of abstractions and their concrete dependencies. It's also probably the one that is in the worst shape of all of my repositories at this point. So a good opportunity for you to help out with that if you feel like making pull requests, adding in abstractions or their implementations. Please feel free to do so. And I am one of the founders of Arizona GiveCamp. Now, GiveCamp is an international organization that does coding for charity. So we put a bunch of developers in a room with a bunch of local charities, and we spend the weekend coding for those charities. It's a lot of fun. I don't believe there's one around here. So if anyone here or anyone watching on the stream feels like they are interested in, hey, you know what, I'd like to have one around here, and I'd like to help make that happen, let me know, and I'll do what I can, provide, hopefully some resources and some guidance to get that going. So, loose coupling. Ultimately that's what we're talking about here, right? We're talking about design patterns and ways we can get loose coupling. So why loose coupling? Why do we need to have? Why is that important? And the answer really comes back to total cost of ownership. It turns out that very little of the costs of building our applications or cost of our applications over the life cycle of the typical application is in the initial build. The vast majority of the costs, sometimes estimated as high as 90% of the total costs, are in maintenance and extension. So it makes sense that we should spend, assuming we have the freedom to do so, meaning we don't have to publish or perish, if we're in a situation where we have the luxury of considering total cost of ownership, which is really most of the time, we should do so, and we should do everything we can to reduce those maintenance and extension costs, because that's what will reduce the total cost of our application to our companies and to our customers. And I submit to you that the best way to reduce maintenance and extension costs is by loose coupling. So applications that are tightly coupled, like this blob on the yellow blob on your left, they're very difficult to maintain and extend because all the pieces, all the aspects of the application are munged together. So it's very difficult to change one part of it without messing up other things. So you change something here, you break something else over here. On the other hand, well-designed applications that are loosely coupled have a real separation, have seams between the portions of the application. And these seams allow you to make changes in one area, assuming you respect all the contracts, of course. You can make changes in one area without breaking other areas. So this is what makes maintenance and extension easy and possible. It supports unit testing and all the important things that we do. Now, you're probably familiar with the solid principles. These are the first five principles of object-oriented design outlined by Robert C. Martin. Two of these principles, the single responsibility principle and the dependency inversion principle, directly relate to the coupling of an application. So here's what we're going to do today. We are going to look at those two design principles. We'll talk about them. We'll see fairly briefly what they are, what they mean. We'll look at a sample tightly coupled application, and then we'll talk about some design patterns and how we would start applying those design patterns and rebuilding our application into a loosely coupled application. So let's start off with the single responsibility principle. Single responsibility principle, the first, the S in solid, right? It says that a class should have one and only one reason to change. Now, class there is very much a key word. When we talk about a class, we're talking about the code that is then instantiated to become an object, right? So it's the code that we're talking about. We're not talking about the state of an object. We're talking about its code. And that code should have only one reason to change. So you should be on the lookout. Are you familiar with BOLO? Be on the lookout. Be on the lookout for when an object's code has to be changed for more than one reason. For example, if you were to change a database field, or if you were to change a business rule, and in both cases you would have to change a single object's code, that's a code smell. That probably means you've violated the single responsibility principle. Does that make sense? Yeah? I'm getting no feedback from you here. All right. All right, the second principle, the last of the solid principles in this case, is dependency inversion. And that says that entities should depend on abstractions, not on concrete implementations. So we don't want classes, we don't want clients in this case, to have knowledge of how our dependencies do their work or what they're actually doing. They should only have knowledge of the capabilities of those dependencies. So again, you can be on the lookout for when the object needs to know those details. For example, if a business layer object, and this is the kind of the canonical example here, if a business layer object needs to know that it is being persisted in SQL Server and needs to have knowledge that SQL Server is being used here by whether, in any way, if it has to have a SQL connection string, or if it has to have something that is basically tied to SQL Server, or if you're using Postgres, a Postgres database, what have you. If that's the case, you've probably violated the dependency inversion principle. And those are going to make, violations of those are going to make your applications tightly coupled, hard to maintain, and hard to extend. So let's take a look at an application that violates some of these principles. Our application here is it's a kind of a classic application, right? We are a company, our company here right now, we have to set up a lot of meetings with clients for whatever reason. We're probably trying to sell them something, you know how we are. So we're going to set up meetings, and we have a meeting system. And that's a third-party system. Maybe it's Exchange or something else. And we can get data out of that and get a list of all the meetings that we have scheduled, okay? And we have a catering system. And we need to be able to feed the appropriate meetings into the catering system so that those meetings that are appropriate to be catered can be catered. But those are our business rules. The business rules are those things that define which meetings need to be catered. So we have an application that runs in the middle between these two that gets the data from the meeting system, applies our business rules to it, and then calls off to the catering system and says, here are the meetings that we need you to cater, and here's the information you need to know to be able to cater those meetings. So let's look at that code. Now, I'm going to tell you, I'm not quite sure how Danny Kaye became the theme of the demo for these presentations, but I'm really glad he did. Just kind of happened that way. All right. Here is a very simple C# application in Visual Studio for creating this file. And you'll notice at the top, this is a single solution, so there's only one solution here, and it's actually called Create Catering File. So it's got the fact that we're dealing with a file itself built right into the name of the application. Probably a good idea, actually, in this case, because that's all it can do. It's a console application, and it's written fairly well. It does a lot of good things. It takes the arguments and passes them into a collection, and it pulls those arguments back out appropriately in an easy to understand way. It constructs a stream writer and for the output. So it's writing that using a stream to do that. So there's a little bit of an abstraction there. And then it takes the input file and it constructs this month object. So I should mention that the file itself is a month worth of data. So our business process right now is we get this file, we extract it from the system, and it comes out as a file that has a month's worth of data in it. And the file name, by convention, is the year and month that we're talking about. So we built some intelligence into the actual file name itself. So we take that, we pass that along to the month object, which inherits from stream reader. So it's tightly coupled to the fact that you need a stream. Streams are usually files, but they don't have to be, so there's a little bit of a better abstraction there. And then from here, it actually then calls the write catering output on the month object, which loops through and passes in each line. So it reads each line right here and passes that to a meeting object. So the meeting object is what is actually going to read the line, parse it out, we can take a look at that, and construct a meeting object. We've probably all written programs that are very similar to this. This is not bad code, but it is tightly coupled. Because if we want to take, good example, we need to, we get a new meeting system now. And we need to interface with that, and that system has an API to it that I can call using, maybe web API or RESTful API, something like that. In order to go in here and change this application, I basically have to completely rewrite it because all of the logic is mixed in with knowledge of that file system and that file format. So here's what a starting point might look like for a new application, one that respects these design principles. Now, there's a lot more projects in here. So it might look like it's more complicated, but each piece of it is actually much, much simpler. And we can drill into what each piece does here very briefly. So here is our, it's also a, it's still a console application. So it gets arguments, but we have some to-dos in here to fill in. And we'll do that over time. We have a common library here that holds our entities, and these entities are the business representation of our domain objects. So in this case, we have a meeting, and this is what a meeting means to us, and we have a catering event. That's what a catering event looks like to us, and we have some interfaces in here. So here's the two interfaces that we'll be using as we go forward. And we'll look more at this as we go forward here. All right, so we do have a tightly coupled application. We violate the single responsibility principle because changing the business logic or data structure requires changes to the same objects. And we violate dependency inversion because we need to have knowledge of that file stream, the file itself, or the file structure, in order to be able to read the data and write the data and such. So we've tightly coupled the two primary aspects of this application, the data and the processing. So we're going to use some design patterns to help us solve these problems. A design pattern, you may be familiar with it, is an abstract solution to a problem. So it gives us sort of a framework to follow, a pattern to follow, prototype, whatever your preferred term is, that we can use to implement a solution. It also gives us a common language. So it's a way we can talk about it. I can go up to someone who is also familiar with the repository pattern, for example, and say, let's use the repository pattern here, and we understand each other. We have that common language. And one of the foundational patterns is the facade pattern. I say it's foundational because there are several other patterns that are built on it, and we are going to talk about those today. A facade, however, is just a simplified view of an API. So it's exactly what the word means. It's a false front. It's creating a seam in the application where you can simplify the view and abstract the caller from knowledge of the underlying API. That's really valuable because we can create a special type of facade called a repository. A repository is a facade that sits in front of a data store. And this can be any type of data store. Doesn't matter what type it is. So it has the same goals as a facade. It's designed to abstract the caller from the implementation and simplify that API. But it's different in that it is specific to data stores, and it has some best practices and a kind of a well-known structure that is generally followed along with it. And so a read repository, for example, might look something like this. Now, I do believe it's a good idea to separate read repository from write repository. If you're familiar with the interface segregation principle, which is another of the solid principles, best to separate them out whenever you can. Now, that being said, that doesn't mean you have to implement them separately. You can have the same object implement both read repository and write repository, but the interfaces themselves should be separate because the underlying client should only have knowledge of what they need. All right. So actually, before I go on there, I've got a couple of sample methods there. For example, you might have a getAllMeetings method, and that would return a collection of some type of the meeting object. It's always a good idea to have, or at least by best practice, is to have a repository have a single top-level object. So in this case, it's a meeting repository. Its top-level object is a meeting object. Okay? So that getAllMeetings method could return a collection of meetings. In .NET, that's usually IEnumerable of meeting. In other worlds, it's an array of meetings. And then a write repository might look like this. We might have an iMeeting write repository with a save meeting method that takes the object and persists that object. We could have a method that takes all of the different properties of the object and persists that. You could even potentially have one that's save meetings and it takes a collection of meeting objects and persists all those. Although that's a little more complicated, there's a little danger there. So at this point, I often have people say, but do we really change our data stores? I mean, how often do you really go about changing from SQL Server to Oracle or something like that? We just don't do it. And that's true. We rarely will change directly from a SQL type database to an Oracle type or something along those lines. But the fact is we do change our data stores far more often than we think. In this example that we've been working on, or that we're going to be working on, we're changing from a file-based store to something else, maybe a web service. But the fact is, you actually change the data. If we're doing our development well, we actually change the databases every time we run a test. Now, everybody here is testing their applications and doing so in isolation, right? Yes? Yes, yes, we are. Good, yes. I see a lot of people saying yes, so good. To do that, we have to be able to replace the database with something else, some kind of mock or some other data store. So we're actually changing the database every time we run isolated tests. But we also change databases whenever we add an API or a caching layer in front of it, or whenever we go from a local installation, an on-premises installation, to a cloud installation. We are changing databases all the time. So I highly, highly recommend that every data store that you implement be abstracted by a repository. Good practice to do it. All right. So this is just in general terms how you might implement any abstraction. And I don't know how well that can be seen, so let's zoom in a little bit here. Okay. So the top line, this is your capabilities. This is the interface that is actually describing what the capability is. So this is all we ever want the client application to know. It's an iMeeting read repository, and all it can do is get all meetings, and it returns an IEnumerable of meeting, or a collection of meetings. That's our capability. And every implementation of this will have that capability. And now, in this case, what we're doing is we're defining a file meeting read repository. So our implementation here uses the file system to implement that. And the file system requires that we have a source path. But that's very specific to a file system. A database wouldn't require that. A web service wouldn't require that. It would require a URL or something different. So it's very important that when you're defining your abstractions, you never put anything on the interface that isn't common to every implementation. If you put the details of the fact that it's a file system on the interface itself, what have you got? You've allowed the implementation, the details of the implementation, to leak through your abstraction. That's what we call a leaky abstraction, and you don't want that. That will make maintenance and extension harder down the road. So how you handle that is you pass that kind of information in on the constructor. You construct the object with that information, you hold a reference to it, and then all the interface methods here are generic. So it's available, because I've held a reference to it here, it is now available when we call get meetings. I can go back up and say, oh yeah, here's my source file path, I will use that to load the information. This is making sense? Okay. All right. So once we have done that, once we take that repository and put that in place for the source file, so we read our file now from a source file, we have a less tightly coupled application. Now, I'm going to tell you, if you choose to look at it later on, there's a GitHub repository where it has all of these steps in separate branches. So you'll be able to go through and look at it and say, all right, here's the first step after we put in a repository, here's the next step, et cetera. I'll show you that as we get back into the code. Because we're doing this in 40 minutes, I'm just going to show you the results of it at the end. All right. So we can now change our business logic and data, our source data, independently because we pulled the repository out. But we still violate the dependency inversion principle because we have to know that what we're calling is this particular implementation. We have to basically say, give me a new file repository. We don't want that. So let's look at dependency injection. Dependency injection is an implementation of the dependency inversion principle. Okay? It gives us a way to store these abstractions and pull them out so that our client objects do not have to have knowledge of the specifics of those implementations. Okay? And it gives us that well-known interface for doing dependency resolution. There are a number of frameworks out there that do this. This actually came out of the Java world quite a number of years ago. In the .NET world right now, there's actually, well, there's a number of them, but There's one built into .NET Core right now. So, and that's the examples that you'll see today. That's what I'm using. There are some systems that will allow you to automatically wire up those dependencies. So we will simply look for this object needs this interface type, this object implements that interface type, and it can automatically wire them up for you so you don't have to do anything. Best practice today is usually to have a configuration area that's at the context level of your application that actually does that, where it says, I want to use this dependency, and this dependency, and handle that in the configuration section. And then none of the underlying objects need to mess with that, need to be aware of that. They only go to the container, which is basically a bag of those dependencies, and say, I need this capability, give it to me. So it looks something like this. We have a client down at the bottom that holds a reference to that container. So we built up this container, and this container holds all our dependencies. This is our dependency bag. Container might hold a SQL data provider or a file data provider, either of which implements that iData provider interface. Now, it can actually hold both or multiple implementations, but there's a little more complexity there. We're not going to talk about that today. So let's just assume it holds one of these implementations. The client is only aware of the iData provider. It tells the dependency bag, I need an iData provider. The dependency bag just gives it whichever one it has. So the client itself is not aware of what it's using. It only knows the capabilities. And here's what that querying might look like. So this is our client object. We pass in on the constructor, we pass in a reference to that container. In the .NET Core world, that is an iService provider. We hold a reference to that container so that down in the actual methods, we can say, get service, and give it the interface type that we want. So give me a service of type iMeeting repository. And that will either return the object in the bag, in the container, in that dependency bag, that implements that interface, or it will return null if it doesn't have one. So then at that point, we need to do some null checking and probably give a good error message to ourselves and say, hey, you forgot to put the dependency in the bag, okay? This is how we do good isolation tests. So because we have this dependency bag, we can put our real dependencies in it when we're running in production. But if we're running in a test context, we can put mock dependencies in there. So if we're using a mocking framework, or we can construct our own mock objects, we can take those and put them in the bag. And as long as they implement that same interface, in other words, as long as they present that they have those same capabilities, our client object isn't going to know, and we can do interaction testing with that. We can do any testing we need without actually having to interact with the real dependency. So we can test in isolation. So we fixed our primary single responsibility problem, because we can change the data storage and business logic independently by pulling out the repository. We fixed our dependency inversion principle problem by implementing this container. But now we kind of have a new problem, sort of. We've mixed in our business logic with our orchestration logic. We have two sets of different types of logic that are mixed together. And here's what I mean by that. Typically, we think about our applications as input processing and output, right? Just one follows the other. But what that's really doing is it's saying that this processing step holds both the business logic and the orchestration logic. It is the thing that is actually controlling this, right? It's the thing that says, go get me my input, and then go spit out my output. So we put all of that in that processing step. I suggest to you that it's actually better to think about these types of applications this way. We still have the same aspects of the application. We have a data source dependency, so this is where we get our data. We have our business rules, and we have a target data dependency. But we also have this orchestrator. So now we've separated the actual business rules from the orchestration logic. So that orchestrator can go out and actually direct traffic and say, go fetch me my data, pass that data to the business rules processor, and then go and pass the needed data back to the data target dependency. This architecture here also allows for really nice things like, for example, moving the orchestration piece to something like Azure Logic apps or what have you. Makes for really good, really scalable architectures that are obviously loosely coupled. So what can we do to implement that? And my suggestion, one of my favorite patterns, is the strategy pattern. The strategy pattern is another implementation of the Facade pattern, but this time, instead of fronting a data store like we do with the repository, we're fronting an algorithm or a business rule. So again, the goals are the same as a Facade. We simplify the API and we create that seam in the application. We abstract the caller. But this is specific to logic, and in an ideal world, we make this as functional as possible, meaning we have as few side effects as possible. Makes it easier to test, and it also makes them really good for putting into things like Lambdas in Amazon or Azure functions. So again, it can make our architectures very, very scalable. So here's how I described it in 2017 when I tweeted about it. I said the strategy pattern is to algorithms what the repository is to data stores. It's a well-known abstraction for loose coupling. So really they are analogous. They're two aspects of the same thing, just for different specific purposes. So we would implement a strategy in almost exactly the same way as we'd implement any other Facade. We describe our capabilities on the interface. In this case, we have a should meeting be catered method that takes some data and returns a Boolean. So it's just telling us, here's our business rule. Should it be catered? Shouldn't it be catered? And then in the implementation, we just put our business rules here. Pretty simple. Now this has a real nice advantage too of being able to separate out additional types of strategies. You can have more than one strategy. So in our example, if we had one set of catering rules for if any of us set up the meeting, and a separate set of catering rules for if a manager or a CEO or somebody like that sets up a meeting, like, they get them catered no matter what, right? If we have separate rules for that, we can have two different strategies, and we can simply swap out the strategies, which makes testing these strategies very, very simple because it's reducing the complexity in each of the strategies. So let's take a look at our application now. Once we've implemented these repositories, once we've implemented the strategy, and when we've put those behind dependency injection, let's see what our application looks like now. Wrong one. That one. And I'm actually going to switch over from, I told you there are different steps in the process here. These are the GitHub branches. So I'm going to switch over to this demo D here. So you can go to the demo starting point and then step B, C, and D to see all of the steps in the process. So here's what this looks like now after we do all that. First, we construct a service collection. So this is our container. This is what's going to hold our dependencies. We are going to add the first dependency, the iMeeting repository, and we're going to tell it, here's how to construct this. So here's the object. This is our configuration section right here. So this is where we're setting up our dependencies, okay? And you can see in this case, we still have to pass the file name in. Probably should get that from arguments up here. So I've got a to-do in there for that. Then we construct we tell the container how to create our catering strategy. So that's this object here. And then we call our business engine, this is the orchestration object here, passing in the results of that container. So this build service provider is basically what bundles all of the, in this framework, it takes all of the dependencies and bundles them and puts them into the bag so that can pass it along to the dependency. So now if we go into the create data method of this engine, which is our orchestration logic, you can see we've already stored a reference to that service provider. So now we can really do our work and just use that. So here we're calling get service on the meeting repository, or actually, sorry, here is where we're actually getting the meeting repository out of that container. So we call the service provider get meeting method, get service method for an iMeeting repository to get that repository, and then we call get meeting on that repository to load our data. For the strategy, we call on the service provider, we call get service for iCatering strategy. So we load we get from the bag, we get our dependencies, we get our repository, we get our strategy, we use them, load me my data, spin through, run and ultimately that'll happen down in this lower level object here. We're going to spin through each one of them and call that strategy to say, should this meeting be catered? And then we'll spit all that out. We cool with this? So what have we done? We've taken our data source, we've used a repository pattern to isolate that. We've taken our business rules, we've isolated those behind a strategy pattern. And then we've taken both of those dependencies and we've used dependency injection to isolate them from the rest of the application. But we're missing something here. We're still missing that data target. We've not implemented that yet. Fortunately for us, implementing a target repository, a save repository, is almost identical to implementing a source repository, except it just writes instead of reads. So, your mission, should you choose to accept it, is to implement that data store. You can go and pull down this code off of GitHub. You can go to the demo starting point if you want to implement all of these and experiment with it yourself. You can go to the demo D, one that I just showed you, which is where we are right now, and just implement that target data store, target data repository. And you can use any data store that makes you comfortable. So if you're a SQL Server or a Postgres person, do it there. If you prefer the file system, write it out to the file system. If you prefer a web service, you know what? Write it out to Twitter. That'd be cool, right? All it has to be able to do is implement the capability. So to do that, you will need some resources. You've already seen that I tweeted out the reference to this slide deck, so you can just pull that down and then click on these to go wherever you need to go, or feel free to take a picture if you like. Here's some information on the design patterns, as well as just a couple of resources for some of the tooling that you can use to do some of this, at least in the .NET world, which is where I spend most of my time. So that is what I have for you today, and I see we're out of time, at least as far as the main portion of the presentation goes. Is there time for questions? Okay.
We do have some, like 5 minutes to answer some of the questions.
Okay. If you use DI, your whole app will be coupled to the chosen DI framework. Is that not a bad smell too? We need a DI framework. Okay. So very good question. Yes, there's always going to be some level of coupling. We're going to try and minimize it as much as we can. I had that same question many years ago, and I actually tried to write my own wrapper around the DI frameworks. So I could say, all right, you know what? I don't want to tie myself to a specific framework. I'm going to build an abstraction layer on top of that and only use my abstraction layer. So all I have to do is rebuild the part underneath it where if I ever change DI frameworks, All I have to do is just swap out that intermediate code. I put a facade basically in front of the DI framework. And what I found out was it was too limiting for me. That's how I felt. But there's no reason why you can't do that if you really feel like that is important to you. Since I pretty much stick with the Microsoft implementations for DI these days, I'm pretty comfortable that they're not going to change things too much for me. And of course, all of that stuff is open source now, so I can always just take a copy of their repo and fork that off and use my own implementation of it if I decide, hey, I need to change something, or if I need to, they've moved off onto something else, and I don't want to, I don't want to change my implementation. So that's one of the big benefits of open source. I probably don't have to tell this crowd that, but being able to know that you have the source code for that thing, and if you need it down the road, you can always build that source code yourself and maintain it yourself. There's some real flexibility and some freedom there. Did that answer the question? I hope so. How is implementing both reading and writing interfaces of the repository in the same class not a violation of the single responsibility principle? Okay. I guess it depends on what works best for you. Definitely putting both, having only one interface would definitely be a violation of the interface segregation principle. If it's a repository that, think about what's underlying that. Most cases, what you're building on is some other framework somewhere. So in the Microsoft world, we're probably building on top of Entity Framework. Entity Framework already has the capability to do all that, to do both reading and writing and all of the other things that go on. So it almost doesn't make any sense, because I would have to rebuild all of the same things to create completely distinct read repositories versus write repositories. Most of that work is already done simply by creating the one object. So I have the two interfaces that I'll implement on that same object. The key to that is that the client is only aware of what it needs. If your situation is different, where you don't have to rebuild everything, and you in fact probably wouldn't want to build everything, if you're building all of that code yourself to do all that work, if you're rebuilding all that plumbing, which I really don't recommend most of the time, then that situation may be different for you, and you might want to separate that out and make a more pure implementation so you don't violate the single responsibility principle. Orchestration seems over-engineering in little apps. Yeah, just about anything can be over-engineering in little apps. My demos here are intentionally small and simple to try and convey the point. This application would take me, an hour or two, maybe a little bit longer, to rebuild from scratch. So would I spend a lot of effort on this particular application, on a very tiny application, putting all that abstraction and orchestration in? No, probably not. It's as things grow. Now the problem comes in when things start growing and you say, you know what, now we really need to put this kind of thing in. I can't even think of an application or any tooling, even in something I build myself, where I don't use a repository in front of the data store. There's just too many things that can go wrong if you don't have that repository there, and I can't do any reasonable testing of my business rules without it. Everything else, I kind of only add it as I need it. I look for when I start getting pain, and then do pain-driven development at that point. Well, I need to change this because I'm starting to see unit tests that look kind of ridiculous, or because I'm having trouble, or I'm seeing that I'm going to have to violate certain principles that I'm not comfortable doing in that scenario that I think are going to hurt me later. How we doing? Still good?
A few more minutes.
Cool. What if an interface needs to be modified? For example, the catering, whoops, it just moved on me. The catering depends on the number of attendees. We still need to change half of the application. Yes. So versioning interfaces is loads of fun. Yeah. So I did a very simple implementation there. I do recommend trying to put as many of the parameters as you can on there, but do not break your interfaces, version them. So yes, you're going to have to create a new version of the application if you have to change that, which then means everything that touches that interface will also have to change, and all of the unit tests for all of those things will have to change. So your initial design, these interfaces are critical. These are the contracts between the portions of your application. So when you spend effort in designing things, this is where I recommend spending that effort. Most things I would say let the architectures evolve as much as possible. But these interfaces are critical long-term pieces of your application that you have to version whenever you change them. So be very careful there. And it's also very hard to design these abstractions in ways that are not leaky down the road. Because if you're, I usually take like 3 implementations. If I have 3 implementations of something, I did a reliable messaging abstraction a while back. And it wasn't until I had both a Microsoft implementation, or an Oracle MQ implementation, and a RabbitMQ implementation that I really felt like I had an interface that actually worked and was generic enough and was at the right level to be able to do everything it needed to do. So there's a lot of effort that goes into designing those as well. That's the hard part of all of this. Some of my colleagues are overusing DI and use it everywhere. Is there a rule of thumb where to use DI and where it is useless? Okay. So I have also seen people where what they do is they put every object in a container, and so everything is constructed always by pulling it out of container. I agree that that is overuse. I see them at the layer level. I feel like I'm creating a strategy. I'm creating a repository. So if you think about the repository, what that really is that that's your data layer. The strategy in this case is really your business logic layer. I don't feel like I would need to put every object that's in each of those layers in a container. I just need to put the engine into it, and the engine knows how to do the construction of all the other things that it needs. That make sense? Yeah. Cool. Why inject the container? Why not only the dependencies? Good. This one I've gone back and forth. Sorry? Oh. So I've gone back and forth on this one myself for a long time. I like the idea of saying, kind of declaring my intent. These are what these are the dependencies that I need as an object. So if I say, these are the ones I need, I'm declaring that right up front. What I actually settled on is something that kind of gets me both, because it's more flexible, certainly, to pass in the container and then say, that way I don't have to worry about changing that interface later on. I simply pass in the container and let it do the work. Now, some of the frameworks will do that for you, where you can put the dependencies on the constructor, and the framework will handle taking care of that. But that means you would have to create that object itself from out of the container. So there's good and bad. What I've actually settled on is I pass in the container, and then the very first thing I do is check for the dependencies that I need, and throw a good exception, with a good error message that says you're missing this if it's not there. Because honestly, those messages are for developers anyways. They're not customer messages. If a customer ever sees that, we've done something horribly wrong. So those messages are for the developers, which means they're generally design time things. We're going to see them when we do our builds or when we do our development, and that's about it. So that's what I've settled on. I'd be interested to hear on Twitter what you prefer. Thank you.
This is a little present from the craft organizers, and this is you, actually.
Oh, wow, check that out.
So thank you so much.